So this is the fun time where, after lunch, we do a little song and dance and I keep you awake. Maybe not. I want to deal with the question of millions of years in 2 sessions. This session will be almost strictly geology and paleontology, which is not my training, but I interact and live in an environment with geologists and those who think about the fossil record. So I want to summarize a lot of that for you and cover a lot of the questions that come up. And then in the next hour, I want to tell you something that I recently published from Genetics that I think addresses this issue. But we got to deal with the geology first. So in the scope of what we've covered, now we're on to this last point here. What do we do with the claim that the Earth is millions of years old? And now we're encompassing more than just evolutionists. We've kind of dealt with the evolutionary issue in the last 2 sessions and somewhat last night. So now we've got folks who agree that evolution can happen, but they still are stuck on this idea of millions of years. And maybe the most common icon of millions of years is this idea of carbon-14 dating. So if people aren't familiar with radiometric dating, they probably have heard of this because this is what people use in archaeology in addition to some geologic work. So you hear about this Indian population lived this many years ago dated by carbon-14 dating, or this Middle Eastern community lived this many thousands of years ago based on carbon-14 dating. And the principle's really very simple. You got cosmic rays that hit nitrogen atoms in the atmosphere, hit neutrons, and nitrogen's converted to carbon-14. So we breathe out carbon dioxide, take up oxygen. Plants do the opposite. They take up carbon dioxide. And so carbon-14 would be part of carbon dioxide. Plants take it up. Animals, horses, whatever, eat plants, and in that way ingest carbon-14. They die, which means carbon-14 intake stops. Carbon-14 then decays back to nitrogen, and so this kind of acts like a clock. As carbon-14 returns to its original state, the carbon-14 decreases over time, and so the longer ago that fossil formed, the less carbon-14 it has. There are assumptions built into the process. We'll talk about those later. That's just one example of many types of radiometric dating. So anytime you have an atom, a substance that's radioactive, you can use it as a clock, theoretically. So in this case, we've got uranium. It decays through a whole bunch of different intermediates. So this isn't just carbon, nitrogen. We've got all these different intermediates before it finally stops decaying when it becomes lead. And so this is what they would use in geology as well. And there are a whole bunch of other radioactive atoms. Now this happens much more slowly than carbon-14, and so they'd use this method to date rocks they think are older. And there's perhaps nothing that epitomizes ancient time more than the Grand Canyon. They'll say these very deep rocks are much older than the top rocks. Just the fact that there are such deep layers seems to argue to people that this must have taken a long time to form. And the types of processes they might appeal to are something like this. Let's say you have a lake, fairly calm. Maybe there's some river runoff. It'll dump sediment into this lake. It'll eventually sink to the bottom. And this doesn't happen very rapidly, so slowly over time these thin little layers form, and we can see the evidence in the rocks later. And so if you got this rock and see these many multiple layers, and you go to Grand Canyon and this is 2 miles deep, well then of course it must have taken a really long time for these layers to form. That's basically how the argument goes. And this is a diagram then of the fossil record. Some of these layers, especially these lower ones, are found in the Grand Canyon, not all of them. But the evolutionary argument, I want you to see, comes from more than just radiometric dating. The evolutionists will use radiometric dating to argue for ancient time, and you can see these dates along the edges here of these rocks. But just the fact that there are so many layers is to them an argument for deep time. And there's a third element to the argument. The fossils you find in the lowest rocks are different than those you find at the top. So you go to the lowest rocks, you'll find creatures that look nothing like anything we see today. It's like a strange, otherworldly place way down at the bottom of those layers. This is from a reconstruction using fossils from the Cambrian layer. You can see trilobites here. It just looks really bizarre. You go a little further up in the fossil record, you begin to see the first fish. But again, some of the fish you see, like these armored fish, don't look like what we see today. Again, a strange world. You keep going further up, you'll find fossils like this Tiktaalik. Eventually life moves on land. Sorry, that's a little dark. It's supposed to be a representation of what they call the Carboniferous era. You can see these strange trees that look like they inhabit swamps. This is supposed to be a beginning reptile. There's a giant insect. Strange worlds seem to have appeared and then passed. You go further up in the fossil record, plants begin to look a little bit more modern, but you got dinosaurs. Eventually the birds appear. Then round about what they'd call the 65 million year mark, you can see this iridium layer, and it appears that some catastrophe hit. Below that layer you find dinosaurs, above it you don't. What you do find are mammals, but again what you find are very strange mammals. What is this? It's not like anything we see today. Even these horses or horse-like creatures don't look quite like what we see today. You might see elephant-like creatures, but that's what we call a shovel tusk, a gomphothere. Doesn't look like what we see today. What are these? Pronghorns? It's got a two-horn structure sticking out of its nose. Mammals, but very different world from what we see today. Again, all sorts of elephant-like creatures. You got tusks right here coming out of its lips, it seems. You've got rhinoceros-like creatures, but it's a very different horn structure. These are brontotheres. You've got stuff that looks like llamas, or a mix between a llama and an elephant, whatever, you name it. Just strange creatures. Whales eventually appear. Giant ground sloths, unlike anything we see today. Glyptodonts, kind of like a gigantic armadillo. You've got the biggest creature, land mammal that ever lived, the Andricothere. Just look how massive these guys are compared to those creatures down there. Of course, some of the more common ones and fun ones, saber-toothed tigers, woolly mammoths, woolly rhinoceros. There's this sequence in the fossil record. And that, to the evolutionist, says, or even to the old earth creationists, it seems like there were worlds that once existed and passed away. World that existed, passed away. And so 3 lines of evidence the evolutionists, old earth creationists, might cite to argue for an ancient history of the earth, not for a 6,000-year earth, which they'd call the flat earth view. You've got the transitional forms. We, of course, dealt with that this morning. They're basically mosaics. You've got the order of appearance. There are guys that appear, and then the disappearance. Some of those strange Cambrian creatures, again, we don't see today. The dinosaurs appear right about here, and then they're gone. It seems like there was a world that existed and then wasn't. So what's the answer to this? What does the science really say? What are they misinterpreting? So I want to deal with each of these individually, beginning with the fossils, and then we'll deal with the more complicated physics last. So here's a redrawing of that fossil record. Down here again are the bottommost layers, or that's a little washed out. You see sort of the sea creatures, nautiloids, strange Cambrian creatures. Eventually the fish appear, then reptiles, large insects, dinosaurs, birds, then finally way at the top, you've got the mammals. Well, when these layers were being worked out, there were a set of fossils termed index fossils. Index meaning there are signatures of a certain layer. They were so abundant, you could use them as signatures of a certain layer. And that's the point I want you to take home. This may represent the sequence, roughly from bottom to top. This is much more representative of the abundance. And so here's a chart that's really worth chewing on. This is data that I just generated in the last few weeks from a secular database. So the paleobiology database is a freely accessible deposit of all the fossil occurrences that people have reported. So let me explain this. This is not the proportion of fossils that exist today by individual. This is occurrences. So one of our former geologist, Steve Austin, has done a lot of work in the Grand Canyon. He's found a layer that contains what he estimates to be 1 million nautiloid fossils, and they all seem to be oriented in roughly the same direction. So this massive killing of nautiloids. This would show up in the database as a single occurrence. One guy says, hey, I found something, here it is, and here are the different types of creatures. It's not a counting. And paleontologists tell me that some of these numbers would go dramatically up. So this is sort of an underestimate of the point I want to make. if you just take these occurrences and say, okay, there's 1.1 million fossil occurrences in this database, how many of those represent aquatic creatures? And my estimate is about 80%. So that number is probably even higher once you count individuals, because clams are everywhere. Think of those nautiloids. Land vertebrates, the fun stuff we always hear about, dinosaurs, those mammals, only 11%. Plants, a very small chunk. Land invertebrates, insects, spiders, so forth, 3%, and then just a miscellaneous category. So the vast majority of fossils appear to be aquatic creatures. Now, I'm going to drop that number down to 64 just because this database is ongoing. It's being updated. I want to be conservative here, but in terms of the big picture, when you look at the fossil record, don't think of that diagram you see in textbooks. That's probably roughly the order, but if you step back and say, what does the fossil record really show us? It shows us an enormous amount of aquatic creatures. Think cause and effect. The effect is a whole bunch of watery creatures. That implies a rather watery cause. So let's take these layers and look at their proportion of aquatic creatures. So here's a chart where this blue bar represents the proportion of aquatic creatures. The red represents the proportion of terrestrial or land creatures. So at these lowest layers, you are almost exclusively aquatic creatures, and those land creatures don't show up until fairly late, probably near the end of the flood. But the main point is, most of these fossils, aquatic creatures. Now, if that's all we knew, that may not be such a big deal. If we found a lot of aquatic creatures on the ocean floor, well, duh, that's where we find aquatic creatures. But we find nearly all of our fossils on the land. Ammonites, shellfish, in the middle of Nebraska, in the middle of Europe, in the middle of South America, on mountaintops. So that's rather interesting. Almost all of these fossils of aquatic, not only the aquatic creatures, land creatures as well, but fossils almost all on the land. And the layers in which they sit are enormous. So here's one particular layer. You can see it. This is Florida down here. There's Alaska, Greenland. You can see this layer outlined here covers most, or a big chunk, of North America. You think cause and effect. The effect is really big, covers the continent nearly. That implies a really big cause. Here's a section again here. Here's the United States, Texas, Florida, Georgia. You can see this in brown, another gigantic layer. Cause and effect. The effect is very large, implies a very large cause. What else is there that's rather striking from the fossil record? You look at some of these individual fossils, and they seem to deny the typical story you hear about how a fossil is formed. So what would be the typical explanation applied to this particular fossil? Notice the fins here, the tail, the head's over here, and there's another tail sticking out here. So this guy's in the middle of eating his lunch, and he dies. What's the chance that he's in the middle of his lunch, dies, sinks to the ocean bottom, never is scavenged, never touched by bacteria, slowly covered with one thin layer of sediment after another for millions of years, and just happens to be preserved for us to see today? Seems pretty unlikely. If instead this guy was in the middle of eating his lunch and whoosh, was covered by an underwater mud flow or sand flow, that seems a more likely explanation for preserving it in that position for us to see today. Similar with this ichthyosaur fossil. There's its snout, flipper, rib cage, backbone, and oh, lo and behold, look right here. That's a baby ichthyosaur. So this is mama in the middle of giving birth. What's the chance she would have been frozen in that position, just happened to sink to the ocean bottom, slowly covered with sediment, never scavenged, never buried? It seems pretty low. It seems much more likely to have to be buried quickly and protected from scavenging and decomposition. So I call these snapshot fossils. They seem to capture a snapshot catastrophic event. They seem to require quick catastrophic burial. This is an image not of ground round that's been left out too long. Again, sorry, it's a little washed. That's from a T-Rex fossil that's supposedly 65 million years old. And this isn't the only instance of soft tissue being found in the fossil record. We've found numerous examples, well, the secularists have, numerous examples of soft tissue. And this is, right there, it's elastic. You can stretch it. Now, what's the chance that something 65 million years old is going to stay in this state, undecomposed, and be recoverable today? It seems really low. I mean, I'm flabbergasted this thing would last 4,000 years, but 65 million years? That stretches the imagination. So we haven't even talked about the Scripture yet, and we've got all these facts that seem very familiar. So you think cause and effect. What is the cause of the fossil record? Something recent, catastrophic, large, on the land, and aquatic. So a recent, large, catastrophic, watery, land inundating catastrophe caused the fossil record. And if that sounds familiar, my guess is you've read your Bible, because the Bible talks about a recent, large, watery catastrophe on the land, the flood of Noah. So when people ask me about the order of the fossils in the fossil record, I say, whoa, 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 whoa. Let's think about the big picture of the fossil record. What's the major cause? Flood. Establish that, now we can talk about the order of the fossils. I want to show you about something else that's ongoing. So if you're taking notes, don't take notes on this because it's not yet published and still needs to be peer-reviewed. But I think this is just to give you a flavor for what might explain why we find certain fossils in certain locations. This is a mapping project one of our newest staff members has been doing, Tim Clary. He's a geologist. So he's been looking at different wells that have been dug around the United States. The wells dig down far enough, you know what layers they hit, has been trying to map out where these different layers occur. So that neat little diagram of one stack on top of the other, that's not how the fossil record actually looks around the United States. There are different layers in different locations. Now, I don't know if you can see right here, but this is supposed to be red. These layers right here are going down right down the middle of the continent. So Texas, Florida, Washington, Wisconsin, Maine. Right down the middle here, that's volcanic rock, which implies that it came from a volcano. And geologists have been puzzling over when this happened. So it appears that, so the Bible talks about the fountains of the great deep breaking open. This may have been one of the precipitating events, one of the initial events. Earth starts cracking, magma starts shooting up. Now I'm told when something, all this magma, hot molten rock comes out of the earth and goes up, something else has to go down. And if you go to Hawaii and watch these volcanoes, you can see the earth breathing as it will. That's what I'm told. So if you've got the middle of the North American continent ripping open and blasting out all sorts of volcanic rock, something else has to sink. And by the way, there's another group of scientists working on looking at the ripple layers in the rocks. So there are ripple layers in the rocks that suggest here's how the water was moving, here's the direction, and it seems like water was moving from north to south. Think now early flood. Fountains of the great deep break open, boom, these volcanoes erupt, water's coming down, it's hitting the continent, water's moving this direction. Notice in green here are some thick layers. Well, here's a picture of Michigan. If rock goes up, something else has to go down. That's going to create a basin. Water follows the path of least resistance. So you can see how this sinks down. Apply this now back to the United States. I'm sorry, this picture's really hard to see, but Florida's supposed to be down here again, Washington, Maine. So the volcano is going to rip through this part here. That's probably going to create a depression there. Volcano up, land down. And if water is moving this direction, it's going to deposit all sorts of sediments right there. Now, what's going to be deposited first? That's really the question. Here's our little map again. This rips open, this sinks down, water's pouring in this way. In the secular world, or in the non-young earth world, I think there's a real misunderstanding of the flood. You hear people talk against the flood, or give you their view of what they think the flood is like. I think they view the flood kind of like a big bathtub. There's this globe that's kind of like a big bathtub, and God turns the spigot on, and boom, it just mixes everything up. And I don't think that's likely how the flood occurred. Fountains of the great deep break open. God did cause the flood, but I think he used some processes that were not that different from what we see today. Volcanoes erupt, water comes down. So what's going to be buried first if water's encroaching the coast and flowing on the land into a basin? Probably the shallow marine creatures. And what do we see at the base of the fossil record? Those creatures that probably existed in that shallow water. And then as you go up, and as the waves start getting bigger, so this is probably early flood. And I'd say the majority of the young Earth geology community thinks that there was one landmass before the flood, then the continent split during the flood. Well, if you move a continent, that's moving a lot of land. That's going to create enormous tidal waves. So after you've buried the shallow marine creatures, these big tidal waves will begin to bring in the deeper water stuff, like fish, deep sea fish we're not familiar with. And then on up you go, and you eventually bury the land creatures. Again, this is all still work that's ongoing, yet to be published, but just to give you a sense, a flavor for what in the world could be the explanation for the order of these fossils. Well, it's going to be geologic, and I think we've got some interesting hints as to what may have been going on and what happened. So don't think of the flood, that's the takeaway. Don't think of the flood as a bathtub. God doesn't have all these creatures and then let's turn on the divine hose and then splash them all, they all get mixed up. That's what you'll find on the BioLogos website, a version of that. That's probably not what happened. There's very specific events that are occurring on the Earth's surface, and those events lead to the burial of different creatures that occurred in different environments. So Scripture has the answer here to what the fossil record really shows. What about those layers? We've already hinted at them briefly. Those layers are really big, but the evolutionists say there's so many layers. It just seems to defy a flood explanation. And again, apply the bathtub view to this. They say these very fine, thin layers, you're never going to get that in a flood. Faucet comes on, boom, it just mixes everything up. You need a calm and placid sea, a calm and placid lake, some sort of non-catastrophic body of water to form it. Well, if you show this picture to an evolutionist, or if I show this picture to you, maybe you can see it. The picture's a little grainy, but there's very fine layers here. And if you didn't know any better, what would you think caused this? Where would you think you'd find this? That's cheating. You already know the answer. There's the punchline. So pretend you didn't hear that. You might think it was at the bottom of a calm and placid sea. That's the answer you're supposed to say. Well, this is in fact from Mount St. Helens. This is what the mountain looked like in May of 1980. I think I was only 2 weeks old when this thing erupted. And the side of the mountain basically blew up. There was magma building inside of it. It was getting bigger and bigger, and I think an earthquake triggered the collapse of one side of it and basically shot outwards, sideways. You can see that explosion going there. So all sorts of ash, rock being spewed. Here's an image of the mountain, snow-capped before the eruption. Here's looking at the back side of it after, and you can see kind of the top of it basically shaved off. If you look at the front of it, it's even more dramatic. There's where the peak used to be. You can see this enormous crater as it basically blew towards all of you. Here's a more recent image. A lava dome has formed in the middle of it. Subsequently, if you take a satellite view, mountains down here, edge of the crater is right there. That lava dome's right there. It blew up. So up the screen, outward. This used to be pristine forest. So all this hot rock, ash, boom, dumps it this way. Dumped about 1 million trees in Spirit Lake. A lot of them are still floating there. If you ever get a chance to go to the state of Washington and see this, I highly recommend it. It's much more impressive in person than these pictures that I can show you. So blowing out all that rock and sediment, it's going to lay down new layers of rock. That's what happened, about 600 feet of sediment. Subsequent eruptions of a much smaller scale, mud flows, have cut a canyon through those layers that have been laid down. So just to give you a sense for the scale, there's a person right there, and way right there, that tiny little toothpick is also a person. So that's it's about a 100-foot canyon. And those layers that were laid down, those fine, thin little layers were caused by that big kaboom. So who would have guessed that something that precise, that careful, would have been caused by a catastrophe? And yet that's exactly what we see. This canyon here, and this is just to show you, this was laid down in May, these layers in June, and then this one in 1982. This canyon is a 1/40th scale model of the Grand Canyon. So if a catastrophe like Mount St. Helens can do that fine and precise of a geologic activity, what do you think caused this? Now, some geologists might respond and say, well, it seems like you'd need a really big catastrophe. And who's got a big enough catastrophe to do that? Steve Austin has told me he's done a lot of work on coal formation. So Mount St. Helens that's a whole other story, is a testimony to how you could possibly form coal quickly. He's talked to secular geologists about the large coal seams way down deep in the fossil record and discussed his data with these guys. And yes, they acknowledge it has to be a catastrophe, and their question is, well, where would you get one big enough? I think we have evidence for that. Now, what if there was a flood in Augusta? What would you expect the evidence to see? Well, by definition, you'd probably expect to see certain sections of the city underwater, maybe some parks underwater, maybe some roads underwater. If it gets big enough, maybe you'd see some houses underwater. And if it's a significant flood, maybe even whole neighborhoods underwater. That's the definition of a flood. Well, 70% of the Earth's surface is still underwater. That's a view of the Pacific Ocean. Hawaii, New Zealand, there you can see, I think, the Mexican coast up there. All I've done is use Google Earth to rotate it. So you can do this yourself. Go get a globe. Blue fills most of the screen. Rotate it to the Indian Ocean. Again, blue fills most of the screen. There's Madagascar, Sri Lanka, Indonesia, Australia. 70% of the Earth's surface still covered with water. In fact, there is so much water here that if you were to make the whole surface of the Earth smooth, so get rid of all those mountains, get rid of valleys, just take a gigantic Earth-sized bulldozer and scrape it all together. There is so much water here that if you were to do that, the Earth would be covered to a depth of 1.7 miles. Or another way of saying that is, the oceans are much deeper than the mountains are high. And this is not a creationist gotcha. This was an evolutionist who made this point. Alfred Russel Wallace, the guy who was competing with Darwin to publish the theory of evolution, is the guy who made this observation. So what catastrophe would be big enough to form the Grand Canyon? Well, Mount St. Helens was, by comparison, just a tiny little volcano in a small state of Washington, in one continent on a very large planet. And the Bible says the fountains of the great deep broke open to cause the global flood. So what do you think is going to happen if the whole west coast of North America rips open in a sheet volcano? Well, the Grand Canyon is this tiny little crack in the state of Arizona. So you got a global flood, global volcanic activity. It's no problem to lay down something like the Grand Canyon and all those fine layers in a short amount of time. And the Bible describes this as well. Flood of Noah not only laid down the fossil record, but good explanation for those layers that contain the fossils. Well, there's one more piece of the evolutionary story. We've gotten an answer from Scripture that agrees with science. What about this idea of radiometric dating? That's what really tends to trip people up. Well, let's return to that little diagram of uranium to lead. So an atomic process, a very precise process. You can measure this in the lab. You can measure how fast it occurs. What do you think a geologist measures when he gets a rock from the field? Does he watch this process happen? No. He crushes up the rock and measures a ratio of uranium to lead. Now, how in the world is that supposed to give you the time of formation for that rock? Well, you've got to make a whole bunch of assumptions. You've got this parent element, uranium, that's supposed to decay over time to lead. Well, you've got to assume when the rock formed there was no lead present. That would throw off your calculation. You've got to assume that all the lead that's in the rock came from this process. If there was lead at the start, this messes up your calculation. You've got to assume that as that rock's been sitting there, it's never been contaminated or touched. So think of that. Let's assume evolution for the moment. If it's been there 1 billion years, it's got to be untouched. There's been no water coming in, no water coming out, no lead contaminating, no uranium contaminating for 1 billion years. And you've got to assume the rate of decay is constant. Well, that's a lot of assumptions, and it'd be nice to know if they were correct. Here's our basic problem with radiometric dating. You've got a process that has a bunch of unproven assumptions, and you've got an unknown age of a rock. Unknown method, unknown age. Two unknowns, that's basically a math problem. You've got to eliminate one of the variables. Well, the evolutionists say, we know the ages of rocks from evolution. And so this agrees with the ages of evolution. Well, that's circular reasoning. We need an age for a rock that we can all agree on if we're talking about the creation-evolution debate. Well, we just talked about a rock whose age we can all agree on because we watched it form. That lava dome formed in 1986. Anyone want to guess who's not already heard this? How old that rock dates by radiometric dating? That's close. It's in the range. It gives you a range, 340,000 to 2.8 million years. And in fact, every rock of known age, and again, when I say known, I mean known from human history. Every rock of known age gives the wrong answer when tested by radiometric dating. This one in Italy, 2,000 years, 25 million by radiometric dating. Hawaii, 200 years, 600,000 radiometric dating. 85 years, 11 million. 20 years, 1.6 million. There's one exception to this rule. If you go to the BioLogos website, they'll say, we tested Mount Vesuvius, 79 AD, and it gives the right answer by radiometric dating. Well, this is a case of the exception proving the rule. How did they get the radiometric decay method to agree and give the right answer? Well, they tweaked it until it gave the right answer. Do you think when they go into the Grand Canyon to other places, they use the tweaked method or the original method? The original one, of course. And so the answer is the method as it's currently practiced does not work. That's the first problem with radiometric decay. It's inaccurate. And until the evolutionists can show that they can get the right answer, it's in deep trouble. Back to our little diagram of radiometric decay. You might notice that there are these little A's. Sorry, that's very light. A here. That represents a helium nucleus. It becomes a helium atom, so that gas we fill up balloons with. So this process, you've got several things to keep track of. You've got uranium, you've got lead, and now you've got this gas. Well, why do I bring this up? Let's put this in the context of a rock. Pretend this odd-looking structure is a rock. It's got uranium, it's got lead. And over time, this will decay to this. The geologist will measure the ratio of those two. But we've also got something else we can measure, these helium atoms. Now, being a biologist and being dumb, I'd think these would just be locked in there. Well, it turns out this is rather slippery. A rock is a lattice, and the helium can kind of wiggle its way out over time. It happens. And so deep in the Earth's surface, these are wiggling their way out. They eventually make their way into the atmosphere, and eventually they escape into space. Well, you can measure the rate of escape into space. You can measure the rate of movement through the rock lattice. You can do it scientifically. And it turns out that even though this wiggling is rather slow, if this rock is as old as the evolutionists claim it is, there shouldn't be much left. So if this rock formed recently, and this process has been going on, there should be a lot of helium present. Well, creation scientists at ICR have done this sort of experiment that I've just told you. They sent a rock to a secular lab, said, give us the age of this rock by the traditional method. It gives you like 1 billion years. And they said, now measure the amount of helium present as well. And the helium age is 6,000. In fact, so another way of saying it is there's way too much helium in this rock for it to be 1 billion years old. And there's the second problem with radiometric decay. It's inconsistent. You look at two different elements in the same rock, and it gives you the wrong answer. In this case, we looked at helium. There's a third problem, and actually something that points towards recent creation as well. And to understand this, we have to introduce one more physics concept, that of half-life. So pretend this is a rock that has uranium. We want to talk about carbon-14. This is a lump of coal, so let's pretend it has carbon-14 in it. This is former living plant material. Now it's dead, so it's got carbon-14 in it. And over time, that carbon-14 will decay. Well, the time it takes for half of the carbon-14 sample to decay back to nitrogen is what we call the half-life. So after one half-life, only half of that carbon-14 will be left. After another half-life, half of that will be left, and another half, and so on you go. It's kind of like trying to fold a piece of paper in half. You can only do it so many times. So the half-life of carbon-14 happens to be about 5,730 years. Uranium to lead, the half-life is about 1 billion. Now, like I said, like the paper folding problem, you can take this sheet of paper and you can try to fold it in half so many times and eventually it gets stuck. You can take a sheet of paper the size of this room and you'll only be able to fold it so many times. So regardless of how big that sheet of paper is that you start with, you can only fold it so many times. It's kind of a poor analogy, but hopefully it makes the point. You can only divide it in half so many times, then it's gone. That's a math problem. After 1.5 million years, which is a number of halvings, there's nothing left. And this is the reason why evolutionists don't use carbon-14 to date rocks they expect to be 1 billion years old. They'll use uranium lead or something else more appropriate. They wouldn't even think to consider carbon-14. Well, coal seams, again, are carbon. The evolutionists, at least in the United States, think they're 300 million years old or so. So if this coal seam is 300 million years old and carbon-14 will be completely gone after 1.5 million years, the evolutionists would think 298 or so million years ago, carbon-14 was gone, so now in the present, there's no point even looking for it. Well, if this coal seam formed recently, perhaps during the flood of Noah, that's much younger than 1.5 million years, and there should be something left. And lo and behold, there is. And it's not due to contamination. The creation geologists have also tested diamonds. Diamonds are carbon. They also contain carbon-14, and they're supposed to be from deep in the earth, billions of years old. And that carbon crystal lattice has virtually no way for carbon-14 to be contaminated by the atmosphere. The evolutionists, of course, say, well, it's just contamination. You can't do that with diamonds. So this points towards a recent origin of the coal, and it makes the claim of 300 million years old virtually impossible. So this method, as it's currently practiced by the evolutionists, doesn't work. It doesn't give you millions of years. And in fact, some of these same problems gives us hints of the recent origin of these rocks. There's way too much helium in these rocks. Looks like they formed recently. There shouldn't be any carbon-14 in these rocks, yet we find them. Of course, the Scripture tells us that these rocks formed recently. God created the earth, the land, the rocks in 6 days, or during that 6-day creation week. Then, of course, He reshaped the surface of the earth with a flood. The earth is not millions of years old, billions of years old. It's just a few thousand. So the Bible has the answer to all of these questions, and all of these lines of evidence, hopefully you've seen, are weak or totally unpersuasive. There's one thing I didn't deal with. So we talked about transitional forms this morning. We talked about the order of appearance, and I gave you one sort of preliminary idea as to what may explain why we find some shallow marine creatures at the bottom, land creatures more so at the top. Again, even at the top, there's an enormous amount of aquatic creatures. We've talked about the slow layer formation. Mount St. Helens shows us, living example before our eyes, just how much geologic work can be done quickly, given the right conditions, and even how precise, fine layers can be carved by a catastrophe. And we've also looked at the problems with radiometric decay. There's one more element, though, that I really haven't addressed. Again, the evolutionary story about the fossils is these look so different. It looks like another world. It looks like time passed, these creatures lived, and then were gone. Where do we see anything like, that's the question I want to deal with. How do you explain extinction? The evolutionists say these guys lived and then died out. That's why we don't see them today. It looks like a different world. These guys lived, then died out. These strange mammals lived and then died out. These gomphotheres lived and then died out. And Drikotheres, they don't exist anymore because they were part of another age. Woolly mammoths, part of the Ice Age. Rhinoceros, part of the Ice Age. So for the evolutionists, a time sequence helps them understand extinction. So how do we understand extinction from a young Earth perspective? And just to make the problem a little bit more penetrating, consider this number. So if you look at the fossil record, again, most of the fossil record, marine creatures. But if you look at those occurrences in that secular database, and you look at how those fossils are classified, there's, I think, around 600 mammal families, of which only about 150 are still living. I don't think I have the numbers quite precise, but that number is accurate. 70% of mammal families have gone extinct. So you think back to this morning, family is basically the same as kind. Of the kinds that Noah took on the ark, 70% of mammals gone. in 4,000 years. So what's the explanation for that? Well, you have to come back tomorrow, because I was going to cover that in the lecture on the dinosaurs. Now, some of the geology resources. Young Earth covers the problems we've mentioned with radiometric decay, covers Mount St. Helens. This is one of my favorite books out there, because it really hits this geologic, millions-of-year issue head-on in a very comprehensive way. Mount St. Helens has been studied by John Morrison, especially by Steve Austin. They've written this fantastic book, Footprints in the Ash. You know, it's a decent size, lots of pictures, and the pictures tell the story. It's a great coffee table. Look how you can get something like the Grand Canyon very quickly. Now, if you really want to dig into this issue, we didn't bring this book with because it's so large, but if you're a student, you want to go into geology, you've got a geology colleague. This is the Bible of geology, if I can use that term, for Young Earth. So the history of the Young Earth movement, many people trace as to a resurgence in 1961, a Presbyterian press published The Genesis Flood by Whitcomb and Morris. And many people see that as spawning the modern Young Earth creation science movement. This is essentially the 50-year update to that book. Scripture doesn't change, but the science changes. We've got all sorts of new research since 1961. This is a 2-volume set. It basically follows the same outline as the Genesis Flood, but with a lot more updated science. So you want a reference for many years to come. This is the 2-volume set to get. And I'm hoping that we'll be able to go to the PCA convention, the General Assembly, in June and pass that out or make it highly discounted for all the pastors there. Again, we've got DVDs. We've got this Astronomy Reveals creation by Jason Lisle, where he talks about some of the astronomical arguments for billions of years, which I didn't cover in this lecture. He also covers it in this book. He's got a chapter on his idea, on it, which is a really fantastic idea, on how we can get light here very quickly. Again, we've got the simpler version, the full color version. We've got the kids' books. Again, sign up for the magazine if you don't do anything else. We've got a website. I think I've finished a little early, but that's good, because then we can take a break, start earlier, and leave more time for Q&A. So I think we'll take 15 minutes?
Let's do 20.
20. Back at 2:05.
Correct.
And we'll deal with a genetic argument that I think pulls the rug out from under the geologic arguments for millions of years.